Hello, everyone, and welcome to the video episode of Business Battles. As you know, that I have been publishing articles on my LinkedIn newsletter, Business Battles, for I think more than now 6 7 years. It has nearly now getting it to closer to 4,500 subscribers, and I try to publish it mostly at the once in a week or once in a month or even sometime when I feel like something is happening in the world of technology or business. I wrote an article just 1.5 months ago, and the title was Why Chip to Cloud Architecture Will Be Deciding the Winners in the Automotive segment, especially when we talk about the automotive in 2030. Now, my argument, and I got a lot of personal messages and views, and also some of the comments on that article, that by 2030 the car industry will not be divided into ICE versus EVs, as we have seen that the dominance of EV in last so many years has been really accelerating, and we are all witness to that. There is no argument about that electric vehicles have taken the world by storm, and the penetration of electric vehicles in different countries is different. And the most striking thing is that countries like China have taken definitely a very important lead in creating the ecosystem. But even countries like India and of course US and even Europe is now trying to catch up and also understand that it is a reality which is hard to ignore. Now, when we say that in 2030, it is not only going to be ICE versus EV, I think the world of automotives will be divided into three parts. One is that it will be software defined, which we know that it is happening for last now almost a decade. Second will be chip to cloud OEMs. We know that OEMs are under a high margin pressure. They are into a pressure of how do they sustain growth, how do they sustain their technology landscape, how do they keep the control on their product and the dominance and the leverage so that they are ahead of the race. So one is software defined vehicles. Second is the OEMs who will be chip to cloud, and the third will be all the others. Now, if we look at the way automotive is shaping up, one pattern is very clear, that OEMs that learn to orchestrate silicon, software, connectivity, and cloud as one system will own the future profit pools. Now I'll repeat again, those OEMs who understand and can orchestrate their architectures or orchestrate their product strategies around silicon, software, connectivity, and cloud, they will be having the maximum leverage to own the profits. I was reading a data somewhere that always the OEM's profit has been in higher single digit, but it has been now moving down into lower single digit, and that's a concern for the whole world. That how can you really sustain, because automotive is a industry is the leading indicator of any economy, so its survival, its thrival is very important. And if the margins start eroding, then it will be difficult. So it means the OEMs have to come up with a strategy which is very important, where they have control on silicon, software, cloud, and the connectivity, because that has become the common baseline. Now, what chip to cloud really means in automotive? In boardrooms, chip to cloud is still used as a marketing phrase, that chip to cloud strategy. But in practice, it is a very concrete architecture, and I'll tell you how. It connects the four important layers. One is silicon and the hardware platform. See, the foundation is this centralized, all the zonal electrical architecture, which is built around high performance compute. You can say the SOCs, the domain controllers, which are very safety microcontrollers and all. And why this silicon and hardware platform is important? The reason is it is important because these are the platforms which are the devices which are running your device, like ADAS, autonomous functions, power electronics for electric vehicles, and core vehicle dynamics. So the hardware must be powerful, it should be energy efficient, and most importantly designed for long life with continuous software updates. Now this is something which we have been experiencing, that cars have been a combination of hardwares for many years, since the inception. But the key thing which now has emerged over the last 15 years, or precisely I will say over the last 10 years, is the continuous software updates which are happening in the car, and that's why the car is becoming more valuable, and you can upgrade your car more frequently. You can push the features and all, and that's why when I wrote the book last year, Hardware to Code, was essentially driving this point that how we have been able to decouple hardware and software so that software update can happen automatically. Now, the reason I say that why chip to cloud is not just a marketing phrase, but it is actually very concrete architecture and operating model connecting the four layers. One is the silicon and hardware platform, which runs your devices and ADAS and all these microcontrollers and all the functions. Second is in-vehicle software platform. See, on the top of, once you've decided your silicon and hardware platform, on the top of the silicon sits this software defined vehicle stack. Your real-time operating system, your middleware, your containers, and this service-oriented architecture across domains. Now, from ADAS to the powertrain to the infotainment, everything which connects there, it is there. Now, this is the point where OEMs essentially decide that whether they will own that platform or depend entirely on a tier one, or even the big technical, tech giants. So the SDV layer is what lets you roll out new features, safety updates, and experiences over the air across the entire fleet. Now, I am taking the clues from the article which I have written on LinkedIn, and you can see that I'll put the link in the comment box. That's where the whole orchestration of these four layers is coming. One is the silicon and hardware, and second is, of course, the in-vehicle software platform. The third most important thing which is coming is edge and connectivity fabric. Now, connectivity has become a game changer. Earlier, we were generally used to be visualizing the connectivity in the form of the mobile phones which we have in our hand, but we have seen that how seamlessly cars have become itself a mobile platform which stores data, communicates to the cloud, and so on. So the edge and connectivity fabric in the automotive industry is very important, and connectivity is no longer a nice to have modem that okay, you have connected something 4G 5G to your V2X etc and satellite links. It is not. It is about now becoming so important that getting this right is very crucial for the success of any car. So what decisions you are taking in the whole hardware and the software layers of the components which are involved in the automotives, it depends highly on what kind of decisions you are making for your edge and connectivity layer. So silicon and hardware, in software platform which sits over the silicon, and third, what decisions and the choices you are making for the edge and the connectivity fabric. The fourth important thing which is now after the AI which is now coming is taking even more prominence is the cloud and the DevOps layer. Now finally, cloud platform hosts the data lakes in which you host the data, your whatever the consumer data is there, car data is there, based on which your analytics is driven. So the cloud platform hosts the data lakes. So all the artificial intelligence, the machine learning, or the digital twins pipeline, whatever you are putting there, and what kind of models you are using to make decisions in your car to control your different subsystems are all now being taken at on the cloud. Now, what kind of parameters or functions you're hosting on the cloud still remains the choice between on the OEMs and the kind of level they are trying to put into their cars. But essentially, these four things have become the defining point of the automotive industry. Silicon and hardware, in software platform, and the edge and connectivity, and of course finally the cloud layer. Now, how can I say what is my true chip to cloud strategy? It means you design and govern over all these four layers together. Now, some OEMs can have a great strategy in their silicon and hardware. Some may have a great strategy in the in-vehicle software platform. Some may have a good cloud strategy. Some may have a good edge and connectivity layers because of the supply ecosystem. But essentially, the chip to cloud strategy completes its, I would say, the real meaning of that is completed when you orchestrate all these four things together as a one. Now, most important thing which we come, why this architecture or this combination of four layers, and who controls these four layers, or who finds a mojo in these four layers will be the winner in 2030. See, the reason is the silicon content and complexity explosion. The modern level L2 or L3 and the vehicle already carries more than 1,000 semiconductors. There was a time earlier in 1960s or 70s, and it's my very favorite example I use. We used to have maybe a very small electronic base, and then we have seen how the ECUs kept on getting added, even to a state of 108 or 110 plus ECUs got into the high-end cars. And when you have so much of ECUs, you have thousands of semiconductors, devices across sensing, computing, connectivity, or it keeps on rising. So it got three implications when this kind of high rise of semiconductors was happening in the automotive industry. One was that OEMs that treat semiconductors as a strategic asset, not just a purchasing line item, will co-design their own sensing platforms or controlling platforms with the chip makers and tier ones. That is number one. Second is centralized compute architectures will replace today's array of ECUs, and we are seeing that you're combining different ECUs. So you are seeing the emergence of, instead of a distributed computing or a controlling system, you're seeing that it is becoming some kind of a mainframe situation where you are commonizing the multiple ECUs into one, and it is actually going to affect the overall cost of the life of the vehicle as well. Now, the winners will align the chip roadmaps, the software roadmaps, and also the cloud roadmaps into single view. Chip roadmap, software roadmap, and the cloud roadmap. That is where the differentiation is going to come. Now, if I look at the way I have seen, that is, the second point which becomes very important in that software defined vehicles also gives you an important possibility of recurring revenues. Now, we have been talking about connected cars. If I look at what I've been seeing since 2013, and now we are in 2026, in last 13 years we have come a long way, and to some extent monetization has become possible, not to the extent which probably we would have expected, but yes, it at least opens up that if you have relevant use cases for the consumers, you will be able to monetize, and software defined vehicles can create your recurring revenues. So, and these recurring revenues are not just for over the air updates or bug fixing. Actually speaking, the feature activation, upgrades over the period of time. And you have seen, Tesla and other companies have been announcing that I will give this feature for the initial period of time, but then you can subscribe it further and pay per use. So effectively we are saying the more AI, the more computing speed, the more chip strategies, and more powerful our cars are becoming, or becoming almost a moving computer on the wheel, we will see that the possibility of monetization will be on the higher side. Of course, the monetization possibility we have been discussing since 2013-14, and almost to the 2020 kind of a period we could not see much of the monetization, and then COVID struck, then we had the chip issues, etc. But now the 4-5 years of pushback which happened has been highly accelerated by the development of generative AI and the AI companies, and they are definitely going to affect how we are going to activate the features and how you can have more use cases being pushed for the consumers. Now, continuous performance efficiency and safety improvements through new calibration are also happening in the cars. That is definitely no brainer, because now you have far more superior software in loop systems, hardware in loop systems, testing systems. And even the tier one and the tech ecosystem around the cars has been evolving at a faster pace. So this has been definitely a key point in which the automotive industry has been shaping. Now, for OEMs, if you look at 100 years ago, for OEMs, this is generational shift. It's absolutely a generational shift because once you sell your car from your factory, your sale is done, you got the revenue and done. But this is a generational shift that even after selling, if you can monetize and can make money even after you've sold your car, that will be important. And I know many key automakers, you name anyone, right from the smaller ones to larger ones, everyone has created departments and key focus teams to monetize aftermarket. In the aftermarket, I'm not referring to aftermarket hardware fitment or accessories. I'm referring that once you have made the sale of your car, how you are going to increase the revenue generated by your car actually. So that has definitely been the generational shift in which OEMs are now looking not vehicle as a one-time margin, but as a life cycle revenue, and that's a very very important shift. Now, the third important thing which I would talk in the same breath is the data gravity and AI. A connected or a partially automated vehicle can generate terabytes of data per day, and it is generating, and that's why the cloud hosting providers are becoming very very important, and therefore this is very important. So raw data cannot simply be pushed to the cloud. It means it is not only it can be not be pushed to cloud, it is expensive and it's too slow also. So it means the right architecture would be to filter and aggregate the data in vehicle at the edge. Send only the most valuable data or slices for the cloud or AI analytics, and then do the model improvement and do your further analysis. So the important thing is the terabytes of data which the car is generating. How do you filter it, analyze it, and rightly push it? So it means the opportunity of this connected vehicle data to be qualified and then used is also increasing many folds. So that's definitely very very important factor which will come into the pretext of this whole question. Now, the new battleground. Where is a new business battle emerging? Where the OEMs will compete? One battleground which I am distinctively seeing is the speed of innovation. That can you launch new features, new use cases, new service improvements, new safety improvements every quarter. Earlier we used to have the minor changes of the cars, a bumper change, a bonnet change, a light change, or a seat change, or a fabric change, or a color change. But now actually it is going to be how you can actually make changes in your software every quarter or maybe even every month if you are competing in a very intense market. Do your silicon choices in vehicle platform and cloud pipelines support the rapid experimentation and testing? Because a lot of paraphernalia of ecosystem is emerging, new startups are coming, new use cases are coming. How you can really be quick and modular to adapt to that ecosystem. So all that is now redefining. So is your organization structured? Are you ready for that kind of cross-functional development? How much DevOps you have embraced into your organization? So all these questions are becoming extremely relevant. So speed of innovation will be the one battleground where the OEMs are going to struggle and will make an important differentiator. Second battleground will be unit economics and the life cycle revenue. Now, a strong chip to cloud stack lets you extend your hardware lifespan through software, reducing the need for costly mid-cycle hardware changes. Very, very important. So how and what strategy you will be using to reduce the cost, reduce your unit economics, and also increase your life cycle value. The OTA diagnostics, how do you fix and reduce your warranty costs? So that will be very important. The data service driven services will improve your residual values, your total cost of ownership. So all that analytics will become very important. How do you use the data generated by the car? So One battleground of speed of innovation, and second, your unit economics and the life cycle value. This will be the second battleground. The third battleground and the most important battleground will be the ecosystem control. When I say control, that doesn't mean that uh, you do everything by your own self, but what it essentially means how you are stitching your ecosystem of tier ones and tech ecosystem so that no one is losing money, and at least they have a roadmap aligned to your silicon hardware, roadmap aligned to your software, roadmap aligned to your cloud, roadmap aligned to your edge and connectivity, a roadmap which is aligned and orchestrated across these four layers. So this battleground will also be important. So this third battleground of how do you control the ecosystem will be important. So if you control the chip to cloud platform, you can invite the tier ones, app developers, and cloud partners into your ecosystem and say, do this on your own terms, which means just like Apple have invited app developers or even the open source Androids if you look, and they've created their own ecosystem, and therefore it becomes even more powerful. Of course, in terms of automotive, it requires even more regulatory checks. It has to be automotive grade, and higher regulatory checks are there as compared to merely a app developed for a mobile device. But essentially, what we are saying is that yes, OEMs have to develop a capability to control the ecosystem by inviting these kind of players into their arena, and that is very, very important. So if you don't, and if you don't do this, you risk becoming a commodity hardware integrator. Many of the car makers which will vanish, especially the smaller players in many countries, and in fact China has seen so many car integrators coming up and going away, is essentially because of that fact. While the automotive ecosystem and startup ecosystem is brilliant, but still, because of lack of funds or lack of strategies, most of the car makers have just gone bankrupt and then out of the park. So if you do not do this, you risk becoming a commodity hardware integrator, and then probably you can do some selling for a few years, you can some make money, but at the end of the day, your brand will not survive. So that is going to be very, very important. So what is the most important question for the CEOs and the CTOs? Question is for the OEM CEO CTO is, are we the platform, or are we an app, or someone else platform we are playing? So this is very important. And what OEMs and tier ones and semiconductor players must get right to make this concrete, I have made my own checklist and I'm just going to read that out. You can see the article also on LinkedIn. One is that we have to architect for decoupling. Now, when I say architect for decoupling, it means you have to move from dozens of domain specific ECUs to zonal centralized architectures very clearly. So clearly you should have a separate hardware, base software and application layer. So each can evolve separately. You should have a separate hardware, separate base software and separate application layer so that they can evolve separately, and then of course they have to be interoperable. Second checklist is co-design with semiconductor and cloud partners. It is very important. Bring chip makers, tier ones and cloud providers into your single discussion when you are doing your product planning or your platform planning. That will be very important to align with their roadmap, how they are moving ahead. Third is invest in automotive DevOps. Very, very important. I remember 2016-17 or 18 time, BMW in China was adopting DevOps for their car development. And I'm sure that now it will be embraced with many other players. But that is the kind of embracement of DevOps has to happen. You can't you cannot rely on a traditional software development waterfall method of development. You have to embrace DevOps if you want to be agile in that way. The fourth most important checklist is build a robust data and AI backbone. Now this is very important because at the end of the day, what decisions you take to align your roadmaps of silicon, hardware, cloud connectivity and everything, it will essentially rely on how you are using data, how you are using AI. So you have to standardize your data models and your telemetries across branded models. Design the flow of data from chip to edge to cloud and back with clear rules of latency, your privacy, your cost and safety. So that will be also very important checklist. It is becoming a complex, but I would say in parallel, a simplified way to run your business profitably. The final thing, the checklist for this collaboration to happen is align with safety, your cybersecurity and regulations. So ensure that your chip to cloud design is compliant with functional safety standards, cybersecurity, because automotive is a regulated industries. You have all your UNEC, your EC, or NHTSA, or even country specific rules and regulations which you have to comply, and those definitely are evolving. They are very mature standards. New standards are coming into different areas, but that's what it is happening right now. So finally, I would say as a closing thought, I see chip to cloud not as a slogan, but as the operating system of the automotive industry's next decade. We have seen automotive operating system now coming in open source and even closed ones, but I see chip to cloud will become a new operating system of the next decade, where OEMs or players who will master that will be becoming the major chances of being the winners. And the way AI and the way new technology landscape is evolving, you never know. Some player can come and disrupt the industry, but yes, there is a continuous race going between some large players, Volkswagen, Tesla, Toyota. These are the players, and even now Chinese makers like BYD. They're all trying to be in that race, and we'll see how it emerges. Of course, in my further interactions, we will discuss upon how these players are doing, how these OEMs are doing, how their strategies are shaping up, and how they are able to run their business profitably. So by 2030, it is not far away. We are in 2026. In next 4 years, I feel that what we could not achieve in last 6 years in the automotive industry, we will achieve exponentially in next 4 years, and many changes are going to happen in this. So we will, and by 2030, we'll look back and see that the real strategic choice was not EV versus ICE, which some people are doing. It is actually, or you're building your own software or buying it. No, will be, did we design and own a content or a coherent chip to cloud architecture? Did we own a coherent chip to cloud architecture is something which is going to be very important. So if you are into automotives and trying to understand what should be your strategy going ahead, I would be very interested to get your comments on my channel here on Business Battles, or even I'll put the link of the article as well. You can read and give me your comments. What do you think? It is becoming a very complex game right now, because of so many players are coming and so much of development is happening in multiple directions. So it is not easy to be a player in this domain, but I certainly feel that legacy players who have the advantage of knowing a very important part of the automotive system, they have a real advantage if they can make themselves lean and also can reorganize themselves to manage these four layers and orchestrate these four layers together, and also can create a checklist which we just discussed to make sure that they are able to create a coherent chip to cloud architecture if they want to be a winner by 2030. Tell me, how did you feel about it? So till we meet again, thank you very much, and see you again with another episode of Business Battles, and probably something in the area of chip to cloud, silicon, SDVs, or maybe even some of the areas of AI as well. Thank you so much.